today we are going to be looking more at those transformations from yesterday. So our first chart here is just a recap, a reminder of what are all those transformations that we talked about. Again, a very important idea that's going to come up in every unit. F of x is just our parent function, the function without any transformations. Yesterday we talked about x squared. So today let's just say our equation is f of x equals x cubed. If you're not familiar, that's just your little cube graph, your little snake graph. Now when we take that equation, that function, and we add a number to it, k, it's going to move the graph up or down. If we're moving it up, we're going to take that equation and we are going to add a number to it that moves it up 1. If I wanted to move it down, I would subtract a number and that would move my function down 5 units. If I wanted to move the graph horizontally, the shift is going to be changing the x value. That's why it's inside of the parentheses. This is going to move our graph left or right. Now, if you remember from yesterday, this is the one that is backwards. It's the opposite of what you think. So if I see x minus 2 quantity cubed, that's actually going to move my graph to the right 2. If I had f of x equals x plus 1 quantity cubed, that's going to move my graph to the left 1. So horizontal shifting is going to happen inside of the parentheses with the exponent, and it's the opposite way that you think. When we multiply by a -1, it's going to reflect over the x-axis. Yes, there are reflections over the y-axis, but we're not going to talk about those. So this would be a -x cubed. Now yesterday I had it a -1x squared. You don't have to write the -1, I just had the 1 there to make a point of what you were multiplying by. Then we can change our graph and we can make it skinnier or wider by doing expansions or compressions. And when we expand and condense, it's going to be done vertically. There are horizontal shrinking and stretching, but we're not going to talk about that. It expands if A is going to be greater than 1. Remember, we don't talk about positive negative here. Positive negative has to do whether it's reflected or not. And it's a compression if it's between 0 and 1. It's got to be between 0 and 1 because it's going to be that decimal or fraction. So if I have 4x cubed, I have vertically expanded or stretched it. I've made it skinnier by a factor of 4. If I had 1/4 x cubed, then I have vertically compressed it or shrunk it and made my graph wider. All right, so that was our recap from what we talked about yesterday. Now we're going to look at a really important idea with transformations. We're going to be creating 2 new graphs here, and both graphs are going to involve a reflection and a translation, the same 2. So we're going to start off back where we were yesterday, parabolas. We're familiar with them. If you're not, you can always plug in, make a table of values. So my parent function, if I do 0 squared, I'm at 0. If I plug in 1 squared, I'm at 1. 2 squared is 4. 3 squared is 9. But I could also plug in a -1. -1 squared and -1 times -1, still positive 1. -2 squared is positive 4. -3 squared is a positive 9. So that right there, that is my parent function. My function without any transformations. It says, translate the graph up to. Easy. I take my parent function, I take every point, 0, 0, and I go up to. So we're going really back to geometry last year when you literally are just counting every point up 2 spots. And this is where my graph is after I have translated everything up 2. And then my second transformation is take that and reflect it over the x-axis. I'm not reflecting the original, I'm reflecting where I currently am. And if you remember, reflections are all about counting. I'm going to reflect over the x-axis. So I'm going to count 1, 2. So I count 1, 2 to the other side. 1, 2, 3, 1, 2, 3. Same thing on the other side. I see that this is 6 above, so this is going to go 6 below. We can just stop there. And this is where my graph is after I first translate and then second I reflect. So let's see what happens. We're going to do this together. What happens when we do it the other way? So we still have that same parent function of 0, 0, 1, 1, 2, 4, 3, 9, that parabola there. But this time, it says to change the order. I'm going to first reflect the graph over the x-axis. Okay, well I'm at 0, 0, can't go anywhere. I'm 1 above, so now I'm 1 below, 1 above, 1 below, 4 above, 4 below, and then that point up there, 9 above, 9 below. So the first thing we did is we reflected over that x-axis, and then I'm going to now translate that up 2. So I'm at the red graph, I go up 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right, so we did the exact same transformations, but in different order. And what's important to note here is that the order is going to matter. So we're actually going to skip the equation part right now. What did we just discover? The order in which you execute the transformations matters. That is going to be a really important idea. So when we go to write our equation, it's going to matter the order that you're told. So in the very first one here, translate the graph up 2. So we were at x squared. If you remember from our recap, if I'm doing a vertical shift up 2, that means I'm adding 2. But then, that was the first step. The next step was to reflect. And when I reflect, if you remember from our chart, that means that we're going to multiply by a negative. But you're multiplying wherever you're at. And I'm not just at x squared, I'm at x squared minus 2. So when I reflected that vertical shift, which means I have to distribute that negative. So my new graph is at a negative x squared minus 2. Because I had to distribute the negative because the reflection happened and it reflected that vertical transformation. Now the second one though, the first thing I did is what I reflected. So I was now at a negative x squared. I hadn't vertically shifted yet. Then I vertically shifted and added 2. I didn't have to distribute the negative that time because the negative came first, the vertical shift came second. So we notice that we have 2 very different equations. I guess not very different, slightly different, but it does make a difference on where my graph is. So when we move on to the next part of our notes, the order is going to matter. When you describe the transformations, you need to follow the order of operations. So PEMDAS. The first transformation you're going to describe is what happens in the parentheses. Parentheses are that horizontal shift. So the minus 3 is telling me that I'm going right 3. The exponents are those parentheses. The next thing that we talk about is the multiplier. I am multiplying by 5, which means I have a vertical expansion or stretch by 5. Do indicate that it's vertical, because remember there are horizontal expansions. We're just not going to talk about it, so we do need to specify though that it's a vertical expansion. Now this is all from our parent function, which is x to the 4th. It's my equation without any transformation. So anytime that you have a number added to that parent function, each number is going to represent a transformation. So we have f of x is equal to x squared plus 9, quantity squared minus 2. Our parent function there being x squared. It's just x to whatever exponent you have, which means we have 2 transformations because we have 2 numbers that have been introduced. Again, we follow order of operations inside the parentheses first. Inside the parentheses is a horizontal shift, which means, oh, I'm not going right. I'm going left 9. Anything in parentheses is always going to be the opposite direction. And then the minus 2 on the outside means I'm going to be going down 2. All right, so that's given the equation. Describe the transformations. Now we're going to be writing the equation. So we have g of x is equal to x to the 5th. The first thing we're going to do is vertically expand by 2. When I vertically expand, I'm multiplying by that number. So that first shift there is going to make that 2 times x to the 5th. And then we're going to go to the right 11. The horizontal shift happens inside of the parentheses with the variable. So the 2 stays there, and I'm going to go the opposite. Remember, horizontal is the opposite, so this is really going to be x minus 11 to the 5th power. And then our third one is going to be down 2. That vertical shift is going to happen outside of all of this. It's just going to be add that number, subtract that number. So we're going to be subtracting because we're going down. That gives us our new equation after all of those transformations. 2 times x minus 11 to the 5th power minus 2. The vertical expansion, the horizontal shift, and then that vertical shift. Next one. All right, so we didn't start with our parent function this time. This time we started with the horizontal shift, which is okay. We just perform those given to what we have. The first thing we're going to do is vertically compress by 1/2. That means I'm taking 1/2 and I'm multiplying it by everything that I have there. You got to be careful though. This x plus 3, this is locked in by the x squared. So that 1/2 cannot go inside those parentheses. So this isn't really that bad. It's just 1/2 x plus 3 quantity squared. Easy peasy. Then we're going to go right 8. That happens inside of those parentheses, which is right here, which is where we already have something going on. That's okay. We're just going to move it more. So I'm already at x plus 3. If I'm going right 8, remember that means minus. Opposite of what we think. So this is going to put us at 1/2 x minus 5 quantity squared. And then last, we are going up 6. Just add that 6 on the end, giving us our final location at 1/2 x minus 5 quantity squared plus 6. We got 2 more to go and then we are done. First thing we are doing is reflecting over the x-axis. Now once again, we're not starting at the parent function. We're starting with a vertical shift down 9. That's fine. When I reflect, I reflected over where I'm starting. So I have to reflect the equation or that parent function and the fact that I had already gone down 9. So I have to distribute that negative, making it a positive 9. Then I'm going to go right 2, and remember, horizontal shifting happens inside of parentheses with the x. So this becomes x minus 2 to the 6th plus 9. Opposite for horizontal. So right 2 really shows up as left 2, as minus 2. And then down 3. Now there was already a vertical shift out there, so I'm just going to go down 3 from where I was. So 9 minus 3 puts me at 6, giving me my final location at negative x minus 2 to the 6th power plus 6. Last one. And again, the order that you do this stuff is really important, making sure that you're reflecting everything that you have. So we have a parent function this time, x cubed. First thing we do is go up 4. A vertical shift happens on the outside. Easy. And then we're going to go right 10. Horizontal shift happens with the x, and it's the opposite of what you think. So right 10 is actually going to be x minus 10 to the 3rd plus 4. And then we are going to vertically compress by 1/2. So where we are right now, we're taking everything that we currently have and we're going to compress it by 1/2. If you remember from before, we can't distribute the 1/2 in here because this is all locked by the 3rd power. So that becomes 1/2 x minus 10 to the 3rd power. But I have to compress that vertical shift. So I take half of 4, which is going to make it plus 2, giving us our final equation as 1/2 x minus 10 to the 3rd plus 2. Okay, and that is it for our second day of transformations.